Hello everyone. Our today's topic is increasing and decreasing function and local extrema. So let's start with increasing and decreasing function. Increasing function. A function is said to be increasing in an interval which is I. Or I can be defined as the values from x1 to x2. Then the function is considered as an increasing function if f of x1 is less than f of x2. That means the values from x1, the functional values from x1 to the functional and the functional values of a value of x2 is actually increasing. Uh, that is how we define increasing function. Similarly, we can also define the decreasing function in an interval I, which is defined as the values from x1 to x2, and I will be considered as a decreasing function if f of x2 is less than x1. The functional value of x2 is actually less than the functional value of x1. If this mathematical condition satisfies for a function, then we can call it as a decreasing function. Okay, let us look at this curve. Here, you see there are certain edges here. These are the edges of this curve, and this curve is the values from 0 to this edge is 0.8. The values from 0 to 0.8, the function is increasing in nature, and from 0.8 to what to 2.5, the function is actually decreasing in nature. And again, from 2.5 to the value 4, to the value function to the value which is equals to f of 4, the function is again increasing by its values. Again, after 4, it is actually decreasing. So these we can easily visualize the increasing and decreasing property of any function from this curve, and it is defined with this particular statement here. Here, if it is said f is increasing on 0, 0.8, means the f is increasing from 0 to 0.8, and again it is also increasing from 2.5 to 4. We can also explain the decreasing property of this curve. F is decreasing on 0.8 to 2.5, and again it is also decreasing from 4 to 4 to infinite. So this is actually a graphical overview of increasing and decreasing functions. Okay. Now let us look at how we can mathematically define the increasing and decreasing function. We can easily define mathematically the increasing and decreasing property of any function by looking at its slope. Okay, so we can determine the slope of any function which is f of x by f of x2 minus f of x1 divided by that interval. So this is actually the rate of change in any particular function. This f prime c actually defining the rate of change of any function f of x at c. So at C we can define the rate of change. Here it is the difference of the functional values the functional values of that function for x1 and x2 against x1 and x2, and in the numerator in the denominator you actually are seeing the difference between this point. So this is how we can evaluate the slope of that function, which is termed as f prime x. It is also equals to the first derivative of this function. You may realize later. Okay. So let us look at the slope. By determining the slope, which is f prime x, we can determine the increasing and decreasing property of any function f of x. So if the slope is positive in any interval of that particular function, then we can consider that function is as increasing function. And if the slope is negative for any particular function, then for any particular interval, then we can call the function is as decreasing function. Okay. So let us look some example here. For let us look at this example here. F of x is defined as 2x cubed plus 9x squared minus 24x minus 10. This is the function of a function of x, and we are about to see at which values the function is increasing, and at which values the functions are decreasing. Okay, so let's look at how can we define this. Here is the solution. At first, we have determined the slope of that particular function, which is f of x. If we take the first derivative of this function, you may know the way how we can take the derivative. We have to actually differentiate this function with respect to f. After differentiating this function with respect to x, we get here 3 to the 6, 6x squared plus 9 to the 18x minus 24. Okay, so this is the first, this equation is the first derivative of f of x. Okay, so as we have got already the first derivative of this function, now we have to evaluate the solution of that function. We can determine the solution by doing the partial fraction, or you may use any other method that you want. So actually we need to find the values of x where the solution lies. So we can with partial fraction we can determine define this function as 6 into x plus 4 and x minus into x minus 4. So from this equation we can easily say at x equals to minus 4 the functional value will be 0, and x equals to 1 the functional value will be 0. So so this particular function has two solutions, which is minus 4 and 1. Okay, so after determining the first derivative of the function, we need to determine the solution where these first derivatives are 0. So we have got minus 4 and 1. Okay, so so we need to check at that values where how this function actually behaves. So let us look at minus 4 first. If you scale on this x-axis, you may get two values, which is number 1 minus 4, then 1. So these are the two values, minus 4 and 1. These are the two values where actually the solution lies. Okay, the solution of the first derivative of that function lies. Okay, now we'll see what is happening to this function from minus infinity to 4. So this is minus infinity to 4. We need to take any values between minus infinity to 4. Let us take minus 5. Okay, so for the value x, which is equals to minus 5, we have now we'll determine the f prime x, putting x equals to minus 5. So if we put x equals to minus 5 in this function or that function, whatever you like, these are the same functions, then we'll get the result, which is 36 and which is positive. Now remember the condition of increasing function. The condition of increasing function is if f prime x is positive, which is greater than 0, then the function is increasing. Now look at the example here. For the value -5, f prime of -5 is a positive number. As long f prime of -5, which is the all left values from -4, or the left values of x from -4, the function is actually increasing here. The red one is actually the graph of f of x. Here you can easily see the values are increasing up to -4, up to x equals to -4. So we have taken any value which is -5. You may take -6, -7, -8, -100, whatever you want. You will get a positive slope over here. Okay, so that indicates the function is increasing from -infinity to 4. See, the sign of f prime x is positive from -infinity to 4. Again, from -4 to 1, we can take any values from -4 to 1. 0 is one of the values from -4 to 1. So we have taken 0. At 0, f prime x is actually negative value. So here negative value. See, when f prime is negative, the function is decreasing up to the value x equals to -1. Again, after 1 to infinity, we have got a positive slope. Okay, that means here also the function is increasing. So this is how we can define the increasing and decreasing function in your PDF provided. I have provided with this video. You may also see some other examples here. Now let us look at the local extrema. Okay, so local extrema consist of 2 points, which is maxima and minima. Maxima is the maximum functional point where actually f prime, the slope of that function, is actually positive, is going from positive to negative. That means the maximum point of that curve. Okay, so that is the local maxima of any particular curve. Let us see the previous curve here. This is the local maxima. Here the f prime x is going from positive to negative. If f prime x is going from positive to negative, then we may get the local maxima on that particular point. And if f prime x is actually going from negative to positive, we may get the local minima. As you see here, the f prime x, the slope is going from negative to positive. So this is the local maxima. Okay, this is how we can define the local maxima and local minima. And if f prime doesn't change at any particular point, that means doesn't change means the sign doesn't change, then that has no local maxima, local extrema. Okay, let us look at this example f prime x. Okay, let us see, let us explain number 3 condition again. Here, within this range, within -4 to 0, actually f prime, -4 to 0, actually f prime, the sign of f prime, the functional values of the slope of the sign of the slope is actually not changing over -4 to actually 1. So therefore it has no local extrema here. Okay, now look at the example f of x equals to x square into e to the power -3x. If we take the derivative of this function, we may get this this function, and it has two solutions, 0 and 2/3. And as long this function has a particular solution which is 0 and 2/3, and has no no infinite position where x is not defined. Therefore, the critical number type 2 is not available here. The critical type 2 is actually defining the value of x where the function is undefined. So the function in this particular example, the in every values of x, the function is defined, and the solution lies into 0 and 2 by 3. Okay, now look at the changes of sign of f prime x for this particular function. As long as it has two different solutions, which is 0 and 2 by 3. Therefore, we will look up the change of sign from minus infinity to 0, then 0 to 2 by 3, then again 2 by 3 to infinity. So these are the intervals, and let us look at the changes of sign within this interval. So any values from minus infinity to 0, we take -2, and we have got a value which is less than 0. That means negative. We have got a negative value. We have put in here this negative sign. Then again, any values from 0 to 2 by 3, we have taken 1 by 3, and here we have got a positive slope. We have given the positive sign, and again for again at 1, which is in the interval 2 by 3 to infinity, we have got the negative slope. That means it has two extremes. It has two extremes where and the extremes are 2 by 3 and 0, and the sign is changing from minus infinity to negative to positive at 0. Here at 0, the sign is the sign of f prime is changing negative to positive. So we have got an extrema at 0, local extrema at 0, and this is a minimum actually, and the maxima is changing sign from positive to negative, and we have got minima at we have got maxima when the sign is changing from positive to negative at 2 by 3. So this is how we can define the maxima and minima. Here is another example you may see, and in the PDF you have to draw a curve. Some particular examples are given in your PDF. Please try to practice these problems, and give me your feedback. Thank you so much for your time. Thank you.